Hello everyone, my name is Ramesh 21951A04 F 0 of branch ECC section. In this presentation, I am going to talk about Debroglie hypothesis. Debroglie hypothesis. The Debroglie hypothesis proposes that all matter exhibits wave-like properties and relates the observed wavelength of matter to its momentum. After Albert Einstein's photon theory became accepted, the question became whether this was true only for light or whether material objects also exhibits wave-like behavior. Here is how the de Broglie hypothesis was developed. De Broglie thesis. In his 1923 or 1924, depending on the source, doctoral dissertation, the French physicist Louis de Broglie made a bold assertion. Considering the considering the Einstein relationship of wavelength lambda to momentum p, de Broglie proposed that this relationship would determine the wavelength of any matter in the relationship. That is, lambda is equals to h by p. Recall, h is Planck's constant. This wavelength is called the de Broglie wavelength. The reason he chose the momentum equation over the energy equation is that was unclear is that it was unclear with matter whether E should be total energy, kinetic energy, or total relativistic energy. For photons, they are all the same, but not so for matter. Assuming the momentum relationship, however, allowed the derivation of a similar de Broglie relationship for frequency f using the kinetic energy Ek, that is F is equals to Ek by h, where where F is frequency, Ek is equals to, that is kinetic energy, h is Planck's constant. Alternate formulations. De Broglie's relationships are sometimes expressed in terms of Dirac's constant, that is h bar is equals to h by 2 pi, and the angular frequency w and wave number k, that is equals to p is equals to h bar into k into ek, or h bar, that is h bar into w. Experimental confirmation. In 1927, physicist Clinton Davison and Lester Germer of Bell Labs performed an experiment where they fired electrons at a crystalline nickel target. The resulting diffraction pattern matched the predictions of the de Broglie wavelength. De Broglie received the 1929 Nobel Prize for his theory, the first time it was ever awarded for a PhD thesis, and Davison or Germer jointly won it in 1937 for the experimental discovery of electron diffraction, and thus the proving of de Broglie hypothesis. Further experiments have held de Broglie hypothesis to be true, including the quantum variance of the double slit experiment. Diffraction experiments in 1999 confirmed that confirmed the de Broglie wavelength for the behavior of molecules as large as buckyballs, which are complex molecules made up of 60 or more carbon atoms, that is that buckyballs. Significance of the de Broglie hypothesis. The de Broglie hypothesis showed that wave, wave particle duality was not merely an aberrant behavior of light, but rather was fundamental principle exhibited by both radiations and matter. As such, it becomes possible to use wave equations to describe material behavior, so long as one properly applies the de Broglie wavelength. This would prove crucial to the development of quantum mechanics. It is now an integral part of the theory of atomic structure and particle physics, macroscopic objects, and wavelength. Though de Broglie hypothesis predicts wavelength of a matter of any size, there are realistic limits on when it's useful. As a baseball thrown at a pitcher, that is pitch, as a de Broglie wavelength that is smaller than the diameter of a proton by about 20 orders of magnitude. The aspects of a macroscopic object are so tiny as to be unobservable in any useful sense, although interesting to be mused about. De Broglie equation definition. The de Broglie equation is an equation used to describe the wave properties of matter. It is used to uh, describe the wave properties of matter, that is specifically the wave nature of electron, that is lambda is equals to h by mv, where h is marks where h is Planck's constant, lambda is equals to wavelength. Where lambda is wavelength, h is Planck's constant, and m is the mass of the particle moving at a velocity v. De Broglie suggested that particles can exhibit properties of waves. The de Broglie hypothesis was verified when matter waves are observed in George Paget Thomson's cathode ray diffraction experiment and Davison Germer experiment, which specifically applied to electrons. Since then, the de Broglie equation has been shown to apply to elementary particles, neutral atoms, and molecules. Thank you.